Hello, welcome back. This is Mrs. Boots, and we're going to look at solving exponentials. So notice in this exponential equation, the x is in the exponent. Ouch! So we got to get rid of the exponent. And I know some people, they think, oh, cool, I can just divide by 4. Yeah, that's a problem. Okay, so let's talk about why that's a problem, right? Division is opposite operation from what? Multiplication. These aren't multiplying. This is 4 to a power. So, what's the difference between 4 squared and 4 times 2? Yeah, 4 times 2 is 8. What's 4 squared? 16. So, if somebody was going to multiply your money by 2 or square it, which would you rather have? Yeah, I want to square it because it's going to get bigger faster, right? Then I have more money. Go shopping, get myself a new dress, all right? So we need to take care of exponentials. Now we haven't learned the opposite of an exponential. That's in the next unit. So we're going to do what we call same base. What's the base? Yeah, the base is the 4 and the 8. So I want to write 4 as something to a power. So what to a power will get me 4? Okay, so let's think about this. 2 times 2, which is the same thing as 2 squared, gets me 4. So I could write this lovely little equation here, the same thing as 2 squared. But notice we have that exponent still. We got this. It's got to come down. So I'm going to put parentheses and put 2x plus 7. Okay? Just going to drop it down. Because 2 squared is 4. Right? 2 squared is 4. And I just put the exponent on there. Not a big deal. Okay. Well, can I write 8 as 2 to a power? Well, yeah. We can do that. We've done that before, Mrs. Boots. Okay. So 8 is 2 cubed. All right? So I'm going to write this as 2 cubed. Now, same thing that we just did. We got to bring down this exponent. Okay? Got to bring down that exponent. Make sure the new exponent is being multiplied times the old exponent. So I always put them in parentheses. Now notice, what did that do? See these cute little bases? They're the same. You know what that means? I can cross them out. They essentially cancel out. And now I'm just left with the exponent. So I have 2 times 2x plus 7 equals 3 times x minus 3. Isn't that cool? So we basically got rid of the exponential. Now we got a plain old linear to solve. Well, that's easy, right? What are we going to do with the number outside parentheses? Very good. We're going to distribute. So we need to distribute on both sides of our equation. So 2 times 2x gives us, awesome, 4x. 2 times 7. Very good. 14 equals 3 times x. Very good. And 3 times negative 3. Well, now what do I do? Yeah, we got to solve it. Okay, so when I solve it, but I have x's on both sides, Miss Boots, what do I do? Well, that's easy. So we're going to get all the x's on one side and push all the numbers to the other side. Okay? We're being socially cliquish, right? I want all my x's over here and everything else over there, right? So how do I move this 3x to the other side? Yeah, we're going to subtract. And why are we subtracting? Very good, because it's the opposite of addition. So now 4x minus 3x, just plain old x. Now what do I need to do to get that 14 to the other side? Very good. We're going to subtract the 14. Okay, so he cancels out. So I have plain old x equals, oh my, negative 9, negative 14. Yeah, it's negative 23. And that is my answer. Isn't that a whole lot prettier than dealing with this? Okay, so every time we do these problems, we want to get the same base. So we're going to express it as a number to a power. Number to a power. Okay, that number could be 2, it could be 3, it could be 5. It doesn't matter. Number to a power. Then I cancel out my bases, and then I just work it with the exponents, all right? So get the same base, cancel the base, set your exponents equal. You got this.